Is 5a fine? Can I really skip 5a? Who objects? Okay, who objects? Who still wants me to go through 5a? Okay, fine. I think I'll go through everything. Fine. Got it. No problem. Okay. Can, no problem. As usual, the steps are all very standard. The substitution is given. Yes, Christine, I just managed to record it. I missed out question 4. So from 5 onwards, I'm recording it. Is that fine? Okay. Okay, let's look at the substitution here. U equals to EX. We differentiate once, which is no problem. And then we bring the dx over. That clears up this one. du equals to EX dx. And we realize here that very nicely you have a EX dx. Can? Fine. So now the next step is now that EX dx is actually du, and e to the power of negative x is 1 over u. So therefore the next step looks like this. So far so good. And typically we don't like fraction within a fraction, right? So we multiply numerator and denominator by u. So we get something like that. So now the next question is, do we know how to integrate this? This should be within your means. Honestly, this should be part of 18.1, 18.2 kind of standard. Okay, look. E to the power x is u. E to the power minus x is 1 over e to the power x, which is 1 over u. Can? Alright, good. Okay, let's move on. So now how do we know how to integrate this? The trick here, there are two ways to do it. Actually, there's only one way. You do long division to get this. Can I just say again that from here to here is long division. Why? Because this is, look here, this is an improper fraction. Is that okay? Is everybody okay? Type okay, we're okay. Okay, do I need to carry on? Next question. Carry on, just type carry on. Just say if it's understood, just understood, and I will stop. Okay, good. Fine. Filing objections? Good. Okay, just for completeness, I will show you everything from now. Okay, leave you all some time to look at the next few steps, which I think is quite standard. Ask questions if necessary. Shall we move on? Louis, are you okay? You got quiet. Good. Okay, 5b. Okay, I say again, at any point if you feel that, let's say for example 5b, you've got the answer, you think that you are fine, and you want to spend your time just this 5-10 minutes while I'm going through 5b, doing some other things, I'm totally fine. Really, it's really up to you, right? But if you're assured, only if you're very, very assured that you know what's going on. Okay, then you come back. Just put your headphones on. Come back when I reach 5c, for example. Is that okay? Okay, Trigo is the one always the challenging one. Let's start. Okay, u equals to cosine square. Differentiate one time. I get this. And let us keep an eye on what we have here. Look here, I have 2 sine x cosine x. Let's keep an eye on this. Keep an eye here. You have sine 2x. Now you have a 2 sine x cosine x. We should be able to see now that I can change this 2 sine x cosine x to sine 2x. Use double angle formula with a negative, of course. So that if you take a look, I have a sine 2x dx. I have a sine 2x dx here. Fine. Then we change limits. Okay, then this one. Okay, just changing around. Then we change limits. At x equals to 0, u equals 1. At x equals to pi over 4, u equals to half. Then we get this at the end of the day. It becomes so easy. Good. Do I need to explain? Type OK if you're okay. Type not okay if you need help. Do we have questions? Fine. Good question, Angie. What happens to the negative sign? Okay, let's... That means the next step lah. Okay, fine. We will answer that question later. Look, let's see. Anybody has any concern with the 1.5? The 1 in the lower limit and the half in the upper limit. We shouldn't, It's fine, Can I just add this comment here? It's perfectly fine, okay? I said last week, and I'll say it again, it's perfectly fine. When after changing limits, after the substitution, it's still okay. Yeah, I mean, if it's an area question, then definitely it's from smaller number to bigger number. You're absolutely right, Isabel. Okay. Okay, can I just add a caveat to what Isabel said? Okay, look. If the original expression is an area that you want to find. That means you integrate from 0 to pi over 4. This is the graph. You want to find area. This first line has nothing wrong. Okay? Now, if you use substitution to solve this thing, and eventually your next line is a 1 in the lower limit, half in the upper limit, you have to respect this second line just by using substitution. You have to respect it. Do you follow what I'm saying, Isabel? Okay. Okay, what I'm saying is this. Isabel's question is, what if it is an area question? You want to find area between 0 and pi over 4. Okay, this graph. Suppose you use integration to find area here. From 0 to pi over 4, and this is a graph like that. But because you can't integrate it directly, you use a tool called substitution. Okay, the tool is called substitution. After substitution, you realize that now your lower limit is 1, upper limit is half. You should not have any concerns whatsoever. Don't go and change your limits just because it is in the wrong order. Follow what I'm saying? Okay. Good. Okay? Just an example, right? Okay, let's move on. Okay. Once we reach this, yes, Belinda, you're right. Okay. Once we reach this, I think we are fine. Okay, answer done. Okay, quite easy. Sorry, I think I also indirectly answered Angie's question. What happens to the negative sign? Can we all take a look? The negative sign is here. I can factorize the negative sign out here. No problem. Angie, okay. Fine. Angie? The rest okay? Okay, good. 5C. Now, 5C, let's take a look. Substitution. Oh, this is I think one of the more difficult ones. 5C. Never mind, we will try. This is a given substitution. Don't know what to do, just differentiate both sides with respect to theta, dx d theta. What is it? It should be half cosine theta. Alright, therefore dx is half cosine theta d theta. Okay, and yeah, we do, yes. Sarah, just to answer your question, yes. Okay, then next thing we need to do, of course, we need to change the limits, the 1/4 and the 3/4. Alright, yes, Angie. Yeah, look out for the recording later, okay? So we substitute 1/4 into x, solve for theta from now on. We will get sine theta equals to negative half. So now at this point, I want to point all of us to how do we find theta in this case, and theta must fall within the principal range. From your MF15, 15. All right. Just 1 second while I try and look out for MF15. On page, let me see, page 3. Okay, never mind. You don't have MF15 in front of you. Also doesn't. Oops. Never mind. Page 3. This is between negative pi over 2 and pi over 2. Alright? So when you press your calculator, I think it will show up as well. But let's take note. And arc cosine has another principal range, arc tangent another principal range. Okay, but don't need to memorize, it's all in formula list. So you use your GC and then you verify that you get theta equals to negative pi over 6. Is everyone okay? Okay, similarly, I won't go through the other one. I'm going quite slow. I feel I can speed up a little bit. This is the other limit. Okay, then we get the two limits. And then we just okay, Shimin's question. Can somebody answer Shimin's question? While I go through while I show you the answer for this, yeah? Okay, I shall try and answer Shimin's question. Okay, Shimin, if we look at here, sine theta equals to half. Sine theta equals to half. Can see? Yeah, look at the arrow. Sine theta equals to half. You're asking yourself what is theta? Am I right? Now, sine pi over 6 is half. No problems. Pi over 6 is 30 degrees. No problem. But sine 150 degrees, which is 5 pi over 6, is also half. Do you follow what I'm saying? Right? Because sine 150 degrees, which is sine 5 pi over 6, is also half. So theta, you cannot say theta equals to 5 pi over 6 because you must respect this principal range here. Yeah? You must respect this principal range here. Follow? Okay, good. Okay, everybody got to this stage, this complicated looking thing. Am I right? And then don't know how to proceed, right? Pui cannot get it. Oh, sorry. Okay. What I did was, this is square root x 1 minus x. Sorry, I forgot to say this. I did this like that. Okay. I substitute the x like that and 1 minus x like that. Sorry, I forgot to say this. Okay, complicated, complicated. But not really, yeah. Did we all persevere after this line? Good. Very good. I mean, 市民 good. The rest didn't persevere because you anticipate that you couldn't handle, or just give up? Okay, my suggestion is don't just give up. Okay, don't just give up. Okay, you must at least try. Okay, you must at least try. Okay, let's see what happens. Okay. Numerator. What I did was the half and the half became 1/4. All right. The cosine theta remains, 1 plus sine theta remains. I just simplified this line to this line factorizing out a half. So far so good. Just simplify only, no big deal. Correct? No big deal, right? Then I think we roughly know where we are going towards, because you see a 1 plus sine theta, 1 minus sine theta. Okay. Can we know how to proceed now? Do we all know how to proceed now? Please go ahead faster. Go and do on your own, okay? Don't wait for me. Write on a piece of paper and go proceed. Luis, are we okay? Cannot. Didn't hear from you for a long time. Can get answer, Luis? Can proceed. Don't know how to proceed. Okay, my clue is this. 1 plus sine theta, 1 minus sine theta. Okay, can write on your own, okay? Don't wait for me, can? The rest, too. Okay, what I did next is to factorize. This is half times half, you get 1/4. Square root 1/4, I get a half. So I get this. I don't think I need to explain the arithmetic behind this, okay? But make sure that you get a half here. Okay? Make sure you get a half after simplifying the half and a half out of the square root. Okay? Now again, it's irritating. The square root is getting in the way again. Is there any way to get rid of the square root? Again, we use identity, right? 1 minus 1 minus sine square theta is cosine square theta. So again, we ask ourselves, is this line true? Square root of cosine square theta, is it cosine theta? Is it? Okay, before that, I better write this line first. Like that. Wait, I can only cancel this one and this only if this is true. Only if the right hand column is true. Okay, you know what I'm driving at now? Do you know? Do we have an inkling? We can't just say this to we can't just say square root cosine square theta is equals to cosine theta unless we are very sure cosine theta is always positive. Is it always positive? Yep, good, Sarah. Yep, good. Thanks, Belinda. Good. Yes, Isabel. Do we know how to write down to justify? Yes. The rest okay? Or waiting for me to show answer? The rest okay? Yeah, because between pi over negative pi over 6, look here, look at the limits here. Between negative pi over 6 and pi over 6, cosine theta is always positive. Therefore, square root cosine square theta is always equals to cosine theta. You can cancel like that. And this becomes an extremely easy problem of integrating just a 1 plus sine theta, which I am not going to go through in detail, and we get this done. Yeah, exactly what I presented actually, Sarah. It's fine. Yep, at the sides it's fine, no problem. Exactly what I wrote there. Okay, we must be very sure ourselves that we can cancel this one. Because if it's a mod, we can't cancel. If it's a mod cosine theta and a cosine theta, we can't cancel numerator and denominator. We must be very sure that it is a cosine theta here, cosine theta here. Is that right? Okay, I'm going to move on. 5D. 5D also quite problematic. Right. Okay, never mind. We work again. Given substitution, don't need to worry too much. Just differentiate dt dx. At least must write this down. Right, and at least must replace the limits. Alright. The only tricky part about this is if you look at the question, you are supposed to replace dx. So now if we try and write this like that, sorry, can I use another color? Wait, hang on. So now if we try and write the next line and say dt equals to half secant square x over 2 dx. Now the issue here would be that in my given integral I only see a dx. Correct? I only see a dx. Now so now I have to replace dx with, I need to bring this over and substitute my dx. Do you follow what I'm saying? But the problem here is this has an x here. I want to change all the x to dt, and this x is getting in the way. So my suggestion is, because this x is getting in the way, I try to express this expression in terms of t rather than in terms of x. Okay? So my point now is that I will change this to in terms of t. Sorry, Shimi, your question is 5C or 5B? Okay, I can't go back now. I can't go back now. Later, if you have further questions, you look at the recording again. I think it's an arithmetic problem which is quite easy. No worries about it. Okay? And if somebody can answer her question, can answer in the chat box. Okay. Okay. So now I can then do a proper substitution and say dx equal to what? Okay, I can go back to my expression and say, oh, dx equals to 2 over 1 plus t squared dt. So now I wholesale can substitute a dx. Oops, where's my eraser? Can? Do you follow the rationale? Why do I change the x in terms of t? Okay, look. Oops, I just managed to delete something. This is x. This is x. Okay. Is it a how or is it a why question? Yeah, Isabel answered the question. Secant square is 1 plus tangent square. Correct? Secant square is 1 plus tangent square. Can, good. So now we settled this. Alright. Next. No problem, don't worry. X equals to 0. T equals to 0. No problem, huh? This one quite easy. Correct? Tangent 0 is 0. When x is pi over 2, tangent pi over 4 is 1. This one also no problem. So now let's take a look at what we want to differentiate, okay? What do we want to what do we want to integrate? Okay, maybe my fault. I didn't write this down. Let me write this down properly now. We want to. The question is this. The question is this. The question was. Sorry, the writing here is not perfect, but I try. The question was to integrate 1 over 4 plus 5 sine x dx. Of course, with limits, 0 to pi over 2. Okay. Now we still haven't quite answered what look sorry can I just say something? Look, the dx we can replace. The limits we can replace. But we still don't know how to replace this sine x, you know. Do you follow? Because I know tangent x over 2 is t. But what is sine x in terms of t? This is the part that all of us are stuck, right? Am I right to say that? Okay. Can I ask a question first? Can I ask a question? In this context, this line, maybe I look at this one. The arrow here, okay? Yeah. T equals to tangent x over 2. Am I right to say that x is sort of like an angle? Correct? X is like an angle. T is like a ratio. Because when we say tangent 30 degrees is 1 over root 3. Almost, Jeanette, almost. I say tangent 30 degrees is 1 over root 3. What we are saying is opposite over adjacent is 1 over root 3 as a ratio. Okay, maybe I use a fresh page here. Okay, what I mean is this, okay? Maybe I use a different color. Okay, I'm saying, if I say tangent 30 degrees is 1 over root 3. We say this, right? This is 1, this is root 3. Correct? That's what we say, right? So when we say tangent x over 2 is t. Similarly, we can draw a right angle triangle and say, oh look, this is x over 2, this is t, this is 1. Our objective now, so now it becomes a bit clearer, right? But then our objective now is ask ourselves, now what is then sine x? Follow so far? Okay, don't oh my god yet, Victoria. There's still one more oh my god. Look, we are able to answer this question, okay? From this triangle over here, can we find what is sine x over 2? We can't find what is sine x, you know. We can find what is sine x over 2 because this by Pythagoras theorem, this is square root 1 plus t squared. So we can find sine x over 2. We can also find cosine x over 2. If we can find sine x over 2, cosine x over 2, then we can find sine x. This is the oh my god. But it's not beyond you, right? It's not beyond you to understand, right? It's not. No, wait. Okay, I answered the question, Angie's question. I saw that coming, actually. You see it one time, you will know what to do. Because the right angle triangle is a commonly used tool. Let's put it this way. Yes, it's possible, Jeanette. But Sarah, you can't do it for all the questions, you know. Seriously. It depends on the context. It depends on the question. Look, okay. I try and answer your question, Sarah. Look, this is your given substitution. This is what you want to find, right? And you want to find a sine of a ratio. Sine x is a ratio. I see it as a ratio. Now you are given t as a ratio of tangent x over 2. So, other than a right angle triangle, I can't see anything else that can help us, you know. I'm sorry if I'm not really directly answering your question, Sarah, but that's the way it works because you are trying to find ratio. Sine x is a ratio, I see, right? And I can find these two ratios just by the right angle triangle. Exactly. Exactly right. Sarah, you're right. So, okay, let's go out. Let's get out of the. Oh my god, okay, so now my working is this lah, huh? Can? Okay, then you can do your own substitution and you can move on if you are faster. No problem. You can write on your own. No problem. Yes, you're supposed to draw the triangle, Isabel. Otherwise, no. NG. Can I say that double angle formula here? Do you understand? Here, sine x equals to 2 sine x over 2 cosine x over 2. This is a double angle formula. Okay, so now we do the substitution, okay? All one shot, finish all the substitution. That means I have my limits. Oh, this will be quite a bit, you know, Isabel. Let me see. Whew. Let me see. 1, 3, 4, at least 5, 6 marks. Maybe 5. Yep. Okay. All right. Okay. Are we comfortable? This one. This next line, we substitute our. This is our dx. This was our dx. This 2t1 plus t squared was our sine x, and the 4 and the 5 are the same. And we don't forget to change limits. Please proceed at your own pace. Okay, if you have done your substitution and you are confident of carrying on, you can really write. Go ahead. Are we all okay? Type okay if you're okay, please. Yeah, good. Okay, then can carry on. Okay. So now what we need to do is this. Okay. How do I get there? I just multiply the two denominators because anyway I don't like this fraction within a fraction. I see a 1 plus t squared, 1 plus t squared, I multiply out and I simplify. Okay, from this point onwards, I really think it's not that bad. Just understand the principle of it. Okay, I'm going through very fast now. Okay, why? Because if you understand the principle of it, it's not that bad. Really. Okay. So I'm going to factorize. Okay, the principle of it is I don't like this 4 because the denominator is a quadratic expression. Correct? Quadratic expression with coefficient 4, and we all learn in 18.1, 18.2 for quadratic expression in the denominator, the coefficient must be either 1 or negative 1. So I'm going to factorize the 4 out and complete the square. So I'm skipping a few steps, I know, but the idea is very simple: complete the square. Okay, once we can get to this stage, I am going to skip a few steps and I show you the last answer. In fact, I don't even need to show the answer. Answer is given. Any violent objections? Wow, silence. Very scary, this silence. Don't know how to no, 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 Louis, you don't have to complete your square now. I'm just saying that you know the principle of it. Yes, it's a 9 over 16, Shimin. You know the principle of it, that you should know that you should complete a square. Don't bother doing it now if you can't catch up, which is fine and perfectly fine. But you should know that you want to and you should complete the square. Don't bother doing it now. I really don't think we should. Okay, try by all by yourself. All right, later on. Now, then take out a formula list, and you should know that there is this standard integral called MF15. I'm going to quote MF15 now. There's this standard integral called 1 over x squared minus a squared. What is it? 1 over 2a ln x plus a. Okay, I must caution that the mod sign and the plus c is absent from formula. This is what I added myself, but we all should know that we should add the mod sign and the plus c. Follow so far? So now all you need to do is to cast this into this form, because you can replace x with, you can replace the x with the t, replace the a with 4 over 3. So 3 over 4, sorry. Can? So, like that. Okay, pause for pause for. I know. It may look difficult, but it's not. It's not. It really isn't. When you do it on your own, it's actually not that bad. Okay. Are we all okay? Or dying? Don't. It's just because there are a few more letters and numbers doesn't mean that it's more difficult. Right. It's just annoying. Yeah. Should be used the right word. It's annoying. But sometimes, no, really. Sometimes life is about getting through the annoying bits as well, right? Seriously, it's like that. Anyway, Louis, what else can you do at 11:30? No soccer to watch. I sweat off soccer I'm gonna sweat off soccer for 2 weeks. No, just no. You must understand, Sarah. It's not. It's because the team that I support is not doing extremely well. So I. Anyway, yeah. Okay, never mind. Okay, come. Let's get through this mess. Okay, let's get through this mess, which is actually not, which from this point is just substitution. Okay, substitution, just evaluation, just evaluate numbers. Okay, so just substitute 1 in, substitute 0 in, and just evaluate. All right. Alright, just evaluate sub 1 in, sub 0 in, we get this is 1/3 lah, okay? I don't want to go through really, it's fine. Right. Oops, what did I just do? At this point we use laws of logarithm. This is ln half, sorry, this is half, correct? Ln half. This is 1/4. So ln A minus ln B is ln A over B, okay? So then you get, there we get our answer. Okay? Not bad, right? Once you get the answer, you get that sense of accomplishment, right? Yes, very good. Yes, say yes, Shimin. When you get through this kind of mess, you should feel very satisfied. If there's no mess in life, how if you are just very comfortably coasting, you won't feel the satisfaction, right? Nah, you won't. Don't worry. You will get used to it. Okay. Shall we move on to E? Okay. Can I say that the technique used in E is quite similar, in fact similar but easier than the to the technique used in D. Okay, I'm going to type it down. In fact, simpler. When we substitute, when we want to find cosine square theta, we want to change what is cosine square theta in terms of t. Sine square theta is t. It's easier. You don't have to use double angle formula. Can we all try and construct a right angle triangle to do the substitution? You follow what I'm saying, right? Do we all get it? Know what I'm talking about? 5e. Christine, okay, I haven't heard from you for some time. Okay, good. Victoria? Surviving? Christine. Okay, now let's use the same technique. T equals to tangent theta. Dt dx is secant square theta, secant square x, sorry. And then we do all note here that you want to replace dx, and you must change all the x to t. Okay, so sorry, before I go on, are we all following me? Okay, good. Can I proceed 5e? Or are we still at 5d? Can proceed 5e? Good, Belinda, thank you. Good, thanks Sarah. NG, good. Great. Okay. So again, it's the same idea. Your secant square x not good enough. I change it to 1 plus t squared. Because ultimately, this dx have to be changed everything in terms of t and dt. This secant square x not good enough. So therefore, I get this. Dx. So now I can immediately change this dx here. Follow? That's the whole idea, because I can't leave this. I can't leave this thing as secant square x. Then you have x and t together, doesn't solve the problem. Fine. So now the next question is, what happens to the cosine square dx and sine square x? Now given this, again same technique, like I mentioned, same technique as 5D. In fact, easier. Can? So the same right angle triangle. It's just that now this time the angle is x, not x over 2. You just got to answer yourself what is sine x and cosine x. Can? Can. Yep, fine, no problem. If you don't like to find cosine x, fine, no problem. Because sine x plus cosine x is 1. Agree? No problem. But I did lah. I'm not so clever. Okay. Can? Yes, one. So we do this substitution like that. Anyway, not much difference in the work. Okay. So again, we don't like fraction. I pause here for a while. Yeah, we all okay with this line. Can? So we don't like fraction within a fraction. In fact, we just multiply the denominators together here, and we will get something quite nice. Really quite nice. Okay, can I stop here? Because this is really an easy expression to integrate now. If I give this question to you in promos, you would be able to solve it, no? I mean this last line lah. I mean this last line. This is a promo standard kind of question. Yep, you're right. Yes, Isabel. We can carry on, right? My point is we can all carry on now, right? Louis, okay. Can move on. Can carry on now. By yourself. Good. Good, Pui. Okay, done. Thank you. So I'm just going to show the rest of the steps. And we are fine. Thank you for being so on time, so on task, and everybody attending this live class. Thank you so much. So Thursday we will not have the lesson. It's recorded. Question 5 onwards are all recorded. I will upload it soon. I think by tomorrow.